Hello, geometry. Welcome to another week. This is the notes looking at similar right triangles. Now, in here, you might notice a cool and fun word called an altitude. Not an attitude, but an altitude. Now, an altitude, kind of like the altitude that a plane flies at, is the same kind of meaning, but only in the sense that it's talking about the height of something. The altitude is referencing a specific height for a right triangle laid out in a specific way. So an altitude is the height of a right triangle that's laying down where the hypotenuse is the bottom, and we'll call that the base. So if the hypotenuse is the base, straight line, boom. Right triangle, boom. This is the altitude. Because you see, while that's a right angle, the right triangle itself has its right angle up here at the top. So there are two right triangles here. This right angle, that's for the full triangle, and then the altitude, which is the height, with its own right angle. Because in order to measure the height of something, it has to be perpendicular to the ground, meaning it's straight up and down. So if I draw this right triangle in a slightly more normal way, there's one side, there's the other side, there's the hypotenuse, and ladies and gentlemen, this is the altitude. And it is at a weird wonky angle there, but that's because of the fact that it has to be perpendicular to our hypotenuse. And so, just to emphasize it, one more time, that's the altitude, Shazam! And that's the altitude. Shazam! Ladies and gentlemen, the altitude is often represented by the letter H for height. And so the altitude is the height of a right triangle And I could write the next part of the sentence either by saying where the hypotenuse is the base, or just by saying the height of the right triangle from the hypotenuse. Both of those mean the same thing. And so height of the right triangle, where the hypotenuse is the base. And so, ladies and gentlemen, that being said, it doesn't necessarily tell us on how it's creating similar right triangles. So let's dive into that part next. Ladies and gentlemen, let's look at the angles created from this similar right triangle, or from this right triangle with a hypotenuse. And so there's our triangle. It's fantastic. Here's our altitude. Shaboom. Fantastic. I will not like sticky keys, but thank you. And there's the right angle at the top. So, ladies and gentlemen, any right triangle has all three angles that add up to 180 degrees. That means that inside of a right triangle, if one of the angles is 90, then the other two are complementary, meaning they add up to 90 degrees. So let me go ahead and just look at the full large triangle here, the full thing. We have two angles in this full gigantic large triangle. I'm going to make one of them blue, and I'm going to make the other one red. And ladies and gentlemen, what we know is that the blue angle and the red angle add up to 180 degrees. Sorry, let me restate that. The blue angle and the red angle add up to 90 degrees because all three of the angles add up to 180. Now, here's the cool part. Ready? It's going to blow your mind. So, our altitude is defined as meeting at 90 degrees because it's the height, which means when we look at the smaller triangles that are formed here, right? So just to illustrate, we have this triangle here in gray, and then we have this other triangle here. I want to make it purple. Purple's a great color. I do not want sticky keys, but thank you. So we have the triangle in gray, we have the triangle in purple. Within those triangles, the same rule applies about our angles. The angles have to add up to 180. We have a 90-degree angle. In the purple one, it's here. In the gray one, it's here. Actually, you know what? I'm going to color code those two. Here you go. Boom. There's our gray 90-degree angle. Bam. And here's our purple 90-degree angle. So, ladies and gentlemen, because we have those 90-degree angles, it means the other two angles have to be complementary. And in the purple triangle, we already have a red angle. The red and blue angle added up to 90, which means that these two angles in the purple triangle have to add up to 90, making those angles the same. The blue angles are the same size because they both have to add up to 90 with the red angle, because all three of these have to add up to 180. Now in the gray triangle, we already have the blue angle, which means the red angle has to add up with the blue angle inside of that triangle to add up to 180. So let me go ahead and use some letters here. We have angle A plus angle B equal to 180. When you include that other 90-degree angle. So B and A by itself are complementary, and they add up to 90 degrees. Now, ladies and gentlemen, you may be looking at this and may not have fully understood what I just described there. So instead, let me break apart these three triangles. The black one, that's the whole one, the gray one, and the purple one. So first I'll break it up just the way that they are for their orientations. And so we have the black one, that's the full one. I'm not going to draw the altitude this time. I'm just going to draw the black one here. And so what do we know? Well, we have our blue angle, angle B. We had angle A. And then we had our 90-degree angle here. And we know that has to make 180 degrees because of the fact it's a right triangle. Now, let me draw the gray one. And so, ladies and gentlemen, the gray one is in a slightly different orientation here. The gray one has the 90 degrees here on the bottom, but that's okay. Because what do we know about similarity? Similarity means that all the angles are the same and the triangle's just a different size. And so, if all the angles are the same, then it has to be similar. So, here we go. We have our 90 that's already matched up. And in the gray one, we have the blue angle. That's the B right here. Boom. And then the red angle on top. That's our A. And so, last but not least, we have our purple triangle. With its 90-degree angle and its two angles, the red A and the blue B. And so, ladies and gentlemen, all of the angles are the same. In different spots, mind you, but they are all the same because the triangle has to add up to 180 degrees and B and A have to add up to 90. And so, all three of these triangles are similar. They're just all in wonky positions. So, when we talk about trying to match up our triangles, the angle B is going to match up to every other angle B. And angle A is going to match up to every other angle A. And the hard part about this, ladies and gentlemen, is that we are taking one triangle that's actually 3 triangles all layered together, and I exploded it. We're looking at all 3 separate. And the hard part here is that all 3 of them separate are still really hard to track because they're all 3 in different positions and orientations. So, ladies and gentlemen, the thing that I would suggest, the process of trying to match up your triangles to really understand how they're similar, is to take an example like this. And I'll just redraw it and work it out from scratch here. So taking that same sort of example, and instead of trying to look at it as it is, redraw it where everything already is matching in terms of how it looks and where it's positioned. So we're going to take the original, with its altitude, and with the color-coded angles that we had before, So angle B over here, and angle A over here. And so, ladies and gentlemen, from there, I would just suggest taking this triangle and the other 2 inlaid triangles and drawing them out so that they're all looking like traditional right triangles. And then pick the spot that you want B and A to go. It doesn't matter which spot's which, because you're going to make sure all of the sides match when you draw it out. And so I'm going to pick for angle B to be down in this corner, and for angle A to be up in this corner. No reason, just a little bit of whimsy. So what that means then is that the other aspects of the triangle are going to correspond. So, for example, the side here that's between B and A, that's our hypotenuse. So that's going to be the hypotenuse in this other triangle, in the triangle that I just wrote, because this is the same one as up above, but I just oriented it in a way that's going to make more sense. Why will it make more sense? Because I'm going to do the same thing now to the other triangles. So the gray triangle that we had before, boom, boom, boom. I'm going to go ahead and do the same thing. I'm going to draw that medium triangle. And I'm going to make sure that it has, no thank you sticky keys. I'm going to make sure that it has B and A in the same place. So I'm going to put B here in the same place, and I'm going to put A up above. Why does it have an A? Because it's similar and it has to add up to 180 degrees. So where's the A here? Well, the 90 degrees, what we talked about before, is down here where the altitude is. So the value of A is up here at the top. Now, matching up which side is which? Well, the hypotenuse is between your A and your B. So there's the hypotenuse of this medium gray triangle. Here's the hypotenuse of the medium gray triangle. Those are the sides that match. Now, last but not least, do the same thing with your purple triangle. Boom, boom, boom. Awesome. So go ahead and draw it out here. Purple, purple, purple. Oh my goodness, sticky keys, you are incessant. But I appreciate your kindness. No, thank you. And so there's its 90-degree angle. There's its 90-degree angle. And it already has the angle A in this lower corner. Ladies and gentlemen, do not fall into the trap of just putting A down here, because then you're not drawing your triangles to match. We care more about matching up our triangles than we do in matching up the original orientations. Why? Because that's how we're going to be able to tell what is actually similar what actually corresponds, what that means to match, what actually corresponds, so we can solve for missing parts of our triangle. So, ladies and gentlemen, the hypotenuse happens between the A and the B, right? And so, thinking about the triangle that we have up here, we already have our 90. We already have our value of A, so our value of B happens here. So, ladies and gentlemen, the hypotenuse then is between the A and the B. There's a purple hypotenuse. There's a purple hypotenuse. So, let me explain this in a slightly different way now. We've labeled our hypotenuses. We've labeled our angles, the A and the B, in our 90 degrees. Let me give these some more academically rigorous names. What I mean by that is I'm going to label the points in the triangle. Green's a great color. Who doesn't love the color green? A, B, C, and then D down here at the point where the altitude meets up with the black hypotenuse. So, thinking about that, we're going to be able to talk about what matches and what corresponds a little bit more specifically. And we're going to do that by talking about the sides of the triangle with two letters. Ladies and gentlemen, you're going to see the sides of triangles talked about in two letters, but you're also going to see them talked about with single letters. And the only difference there is whether you're referencing the points that are the endpoints, or if you're representing the distance in the middle. And so I want to be able to do both here. And it's going to be color coordinated, so it'll be a little bit easier to follow. The hypotenuse, sorry, not the hypotenuse, but the altitude is going to be h. And then I'm going to use x, y, and then the whole length here is going to be z. But ladies and gentlemen, there's a difficulty here because this z is broken up into two parts, the one in the gray and the one in the purple. And so when we need to reference those two sides, we're going to want to be able to talk about those sides differently. I'm going to use the P for the purple one and the G for the gray one just because those are fun letters. Now, let's start labeling our three color-coded triangles. And ladies and gentlemen, I'm only looking at a few pieces of information at a time because I'll tell you what, there's enough information here to boggle your mind. So really break it down just by the points that matter. All right, so let's start with the letters that are the endpoints first. This red A in the black triangle, well, the black triangle was the full triangle. Hey, there's the red A, so that matches up with C. Just focusing on matching one thing at a time. I'm not looking at the whole picture. Black triangle, the blue B, black triangle. There's our blue B, matches up with A. Black triangle, 90 degrees is our B. And ladies and gentlemen, that's it. Now I'm going to do the same thing for our gray triangle. Here's our gray triangle. Blue B is over here at A. Gray triangle. Our A is up here at point B. So you see on how the letters are different already. And then in our gray triangle, our 90-degree angle is down here at D. And so, last but not least, our purple triangle, our blue B is up here with the other B. The red A is over here with the C. And our 90-degree measure is down here with the D. So, ladies and gentlemen, what I can tell you then for our similarity statements, thinking about what matches and how it matches, in our black big triangle, we have triangle. I'm going to go ahead and do ABC. because it's easy as 1, 2, 3. And that's going to be similar to, in the gray triangle, A matches up with A, B matches up with D, and then C matches up with B. So, ladies and gentlemen, writing out those similarity statements, letter by letter, point by point, angle by angle. The reason why this is so nice and so convenient is because now that we've done all this work, this is the only thing we need to reference in order to know what sides actually match up. AB matches up to AD. BC matches up with DB. And so letter by letter, the order itself tells you what's going to match. So, last one, the purple one. Ran out of room though. Let's go ahead and make some more space there. I'm going to need you to scoot. Ooh. And so our last sets of the last purple triangle now, because of the fact that we matched the gray and black already, I can match the purple with the gray or the purple with the black, and it's going to work either way. The letters are going to be in the correct order for our similarity statement. And so if I use the gray here, A matches up with B. So B is going to come first. Then D second. So D is going to match up with D. And last but not least, the B in our gray triangle matches up to C in our purple triangle. And so BDC is the similarity statement to match with our gray triangle, to match with our black triangle. Whew, that's a lot. But ladies and gentlemen, by going through it step by step, we're able to take a really complicated diagram with a ton of details in it and really break it down so that we can only focus on one thing at a time. Because we can do one thing at a time. That's what we've been doing so far with our similarity statements and our proportions up till now. We have that on lockdown. The only difference is now taking a complicated diagram and giving ourselves permission to pass and do well by only looking at the parts that we need to look at. And so let's do that one last step with the actual letters and variables. So I wrote those in teal, so color matching, teal it is. And ladies and gentlemen, even though there's a lot of other details here, I'm just going to use the actual letters that I've identified already. So CB, what's the length of CB? Well, there's C, there's B, that's Y. Now that Y is going to match with every other vertical line because that's how our A's and our B's match up. We did that on purpose. And so Y is going to match up with every other vertical line. So in our proportions, in our fractions, all those vertical lines are going to be able to be on the top or the bottoms of our fractions. They're all going to be able to match up with one another. And so with BD, well, hey, I know what BD is. B to D is H. Boom. And now C to D. C to D is P. Boom. So all three of those letters, which really would just be numbers, are going to match up to one another and correspond. So do the same thing with this bottom side. AB, A to B is X. DA, D to A is G. And then BD, B to D is H. And last but not least, for hypotenuse, the hypotenuse for the full black triangle was Z. Boom. For the gray triangle, the hypotenuse was X. And then for the purple triangle, the hypotenuse was Y. And so now we have every aspect about our triangles matched up, and the key word here is corresponding. We have every side of our triangle corresponding because of how we drew it. So all the hard work is taken care of. We're able to dissect a really complex diagram, have all the details laid out here. And ladies and gentlemen, while I modeled labeling literally everything we could label, when you actually look at the practice problems, they're probably not going to have every single one of these details. They may only have some of the sides to worry about rather than all three. But ladies and gentlemen, when you go to break that down and label your sides, you have to be extra careful about which side you're actually looking at, because thinking about the wrong side is enough to make your problem go astray. So, ladies and gentlemen, in the next video, we're going to look at actually doing some practice problems and solving for our triangles. Thank you for your time and your work. See you soon.